Good morning once again. This is Mr. Fisher with your Algebra 1 class. Yesterday we had some technology issues, so I want to record this video early again today before school to make sure that you guys get this video. But man, yesterday was a nightmare. My computer locked up and wouldn't work for my class that was in class, so we're working out those glitches. We're also trying to work out this whole Google Classroom thing. As you can see up here, I'm getting tons of emails. Just since last night, I got 73 more emails. And I think what's happening here is when I make an assignment like Thursday's yesterday, and it says a due date of today, well, you guys are kind of doing the right thing. You're using this Google Forms down here to turn in your work, and then I get the submission, but then you guys go to these up here and you turn it in. So I get an email when you turn, and all I'm getting is the PDFs, a copy of the PDFs when you do the turn in. And so I still get this, but now I'm getting twice as many emails on top of the ones that you guys are asking questions on. So it's kind of a little overwhelming for me right now. So we're figuring it out. So I want to try something new today. So I made a folder here where you can see the assignment. So here's the PDF that you're going to see today. And there'll be the video also in this folder when I'm all done. And I'm just going to post this one. So you won't have to turn it in or anything. It's just there giving you the directions and the materials that you need for today. And then when you are finished with the homework, I want to put this little icon under each one, and we'll see how this works, that you'll click on the Fridays, and this is the Google form that you will click on to turn it in. And then I think I will probably only get 30 notifications saying, yes, you turned it in, go check it out, okay? So let's give that a try. It's a little bit different. It gets a little messy here, but I think we can handle it. Here's your assignments. Here's where you submit your work. So we'll see how this goes. All right, so today we're doing multiplication. That's a little bit easier than addition and subtraction of integers, but we're going to do multiplication of integers. And so your warm-up is right here, just looking for the patterns. I realize that your paper that you get, and I'm going to get away from these guys that are pictures from the internet that another teacher was using. They're going to be actual math problems on this warm-up. But basically what I want you to do is take and look at the patterns here that we went from 6, 4, 2, and finish these three numbers. And you can write it out here on these guys if you wish. Just do that. Pause your video. Come on back when you're done. I hope you're back now. And so here we got 0. We should have a -2 here, and then a -4. It looks like we're going down by 2s. 6, 4, 2, 0. Subtract 2 from there, I get -2. Over here, we're starting with the negatives, but we're going up. We went from -6 to -4, so we added 2 to that. We added 2 to this. We're back to 0 again, and here we get a 2, and here we get a 4. It's just a pattern that you're trying to look and see what we have learned earlier in 7th and 8th grade, perhaps, that if I have some signs over here where I have a positive times a negative, I get a negative answer. Over here where the signs are the same, a negative times a negative, I get a positive answer. So that's kind of the pattern that we're trying to establish here with that. So today we're multiplying, dividing integers. Calculators were pretty good for these. I only see one glitch with kids sometimes on using their calculator, and I'll kind of point that out. So you kind of think of multiplication as repeated addition. I don't mean to insult you, but what we're doing here is we're looking at, if I said 3 times 2, that's like addition of 2 plus 2 plus 2. But when we get to negatives, it's kind of the same thing. I have a -2, a -2, and a -2. So I have really a -2, then another -2, which is -4, down to -6. Here's another way to look at it. If you are using a number line, we started at 0, we went down 3, and we're going to go down 3 every time, 3 times. So then we went down another 3, and now we're at a -6. We went down another 3, and now we're at a -9. So your final answer is -9. Shortcut, as I'm sure you know, 3 times 3 is 9. Positive times a negative is a negative. Okay? And here is that rule. Here's what I like to use is when I'm looking and multiplying, I want to focus on the rule down here. if I have the same signs, and you might write this, if I have the same signs like a positive times a positive, I'm going to get a positive answer. If I have a negative times a negative, I get a positive answer. Okay? If the signs are different, like a positive times a negative, then my answer is going to be a negative. Or to reverse it, negative times a positive, I still get an answer that's a negative. Okay, so we should just kind of know what kind of answer we're expecting out of the calculator when we put it in. So here's a couple problems that we can try here. I can look at this problem and I know that a positive times a negative is a negative. So right away I'll put my negative sign there. And we get a negative 24. Now you might try it on your calculator just to make sure. Oh, let me get, oh I know I didn't unplug my, let me fix this real quick. I unplugged my document camera. So you're just looking at my roof. Let's see now if we get my document camera. See it thinking, there we go. I have to do some turning here. Sorry about that. I had it all set up, I thought. Let's see if we can get this. And let's see if we can do a zoom in a little bit here. Sorry. Grab my pen here. Let's see if that works. Alright. Let's see if we can get a picture on my calculator when I turn it on. Yeah, a little bit. Alright, so the problem was 4. So I got 4. I want to use the times. I want to use my negative button. And it was 6. And I get a negative 24 like I just saw. I don't know. It's a little bit. Let me see if I can prop this up a little bit so you can see it. There's a little bit of a glare on. Sorry. We'll figure it out. Let's see how I'm going to solve this problem. Making it worse. I know. I'll use one of my face masks. Let's try that. Still not seeing a 24. Anyway, I'll hold it up like that when I get my answer. There we go. Okay, so let's try something else now. Let's try negative 4 times, and I want to use the subtraction operation and see what happens there. I get a syntax error. So on my calculator, again, I use the negative button. So let's see what happens on this one. Now, I'm going to do 4, but on this calculator, when you hit times, you're going to put in your 6. I mean, yeah, what's the 6? 6, but you have to tell it was a negative 6 and hit enter, and you get a negative 24. Okay, so again, lose your calculator. Now, if you did this 4 times a minus and use the minus operation, 6, we get a negative 2. Okay, so that's not what we want. We want a negative 24. So once again, the goal today is to figure out your calculator. Let's continue the rest of these. Negative times a negative is a positive, and 4 times 2 is 8. You do not have to put positive 8 like that. If we have an 8 with nothing in front of it, we assume it's positive. I'm sure you do that. And here we got a negative times a negative, so that's a positive 35. All right, so today's lesson will go pretty quick. Fractions, we'll have some fractions today, so that will kind of put a little bit of a challenge in for us, remembering how to do fractions. Here we got 3 times negative 4. Positive times a negative is a negative, and 3 times 4 is 12. Positive times positive, negative times a negative is a positive. And we got 6 times 8, which is 48. Okay. All right, earth science. Again, I like word problems. We're going to get a ton of them this year. So we want to kind of start working on reading questions carefully, drawing pictures, and then making sure that we answer the question with words. In this case, a scuba diver is swimming at a depth of negative 12 feet. So that means here's the surface water. He's swimming down here at a minus 12 feet. In the flower garden banks of the National Marine Sanctuary, she dives down to a coral reef that is 5 times this depth. So that means we're going to go down another 12. We're going to go down another 12, down another 12, down another 12. 1, 2, 3, 4, 5. So really now we're all the way down here. Rather than adding negative 12, negative 12, negative 12, negative 12, we just say, hey, let's take 5 times negative 12. All right, so now she's really at a negative 60. 5 times 12 is 60. All right, so that's the shortcut. There's my picture explaining my work and my thinking. What is the depth of the coral reef? Let's answer the question. Here's the question. What's the depth of the coral reef? So we need to say the coral reef is negative 60. And now we have to have units. So if you come up to the problem, negative 60 feet. You could have also said that the coral reef is 60 feet below the surface, because below would be your negative sign. Okay, so this is the answer. All right. I still have pretty sloppy handwriting, don't I? I'm trying to keep my hand off the surface here, so I'm kind of writing with my palm of my hand up in the air. All right, let's do dividing integers. Pretty much the same thing as multiplication, that if we have a positive times a negative, we know it's going to be a negative, but now we just need to know and think in our head how many 9s are in 72. Once again, you can go back to your calculator, speed things up. I've forgotten some of these. I know 9 goes into 72 8 times. So let's see with our calculator. I do 72 divided by, I want to use my negative sign on my calculator. I already got the 72 in there. And so I'm going to say 72 times, what was it, negative 9, I believe it was. Whoops, I don't want to do, see how I put negative 72 in there? So again, I'm going to do 72 divided by, and again, you have to kind of get used to it, 9, but I want it to be a negative 9, and I get my negative 8. Okay, my calculator, again, I'm used to it, so I just go ahead and start putting in 72, and I do the old divided by, and I always use my negative button, and I get negative 8 as well. All right. Practice on your calculator a couple times. I'm not going to make kids do it as much as I did yesterday, because the adding and subtracting seems to be the one that really messes students up. Back to our paper here. Negative divided by positive. I know my answer should be a negative. Negative 4. Negative divided by negative, just like in multiplication, if my signs are the same, my answer is always going to be a positive. So I know this is going to be a positive. 5 goes into 35, 7 times. Okay. I have a star by this one here because this one's kind of interesting. See what you get on your calculator. Pause your video, do the try-its, and then come back. When I did my work, I got negative 9 on this one. I got positive 50 on this one. But on this one, when I did this, and I did negative 42 divided by 0, I got that, divided by 0 error. Now, why would we get that? It's an answer, but what am I going to write on my paper? And what they're saying is I have a negative 42 of something, and I'm going to try to divide it into groups that have nothing. And so since we have something, we really can't divide it into groups of nothing. So what we do is we say this one is undefined. That is the answer. Okay? And we'll get that sometimes. We'll get undefined numerous times in our algebra this year. Now, just because we're here, let's try the opposite way. If I have 0 items in a group, and I want to divide it by a negative 42, let's see what happens on our calculator when we do that. Because I have nothing in my groups, so I just have a bunch of space. And if I try to divide it into 42, whoops, a negative 42. I'm dividing it into 42 little groups. I still have nothing in my groups, so I get out of 0. So be careful on these guys. So this problem here does have an answer of 0. When I do this, I can't divide by 0. So we write undefined. All right, a little bit tricky. This is when I love my calculator now in 9th grade is decimals. All I really care right now about is Negative divided by positive, I know this answer is going to be negative. So since I know it's negative, if you want to save yourself some work, you can just say, hey, I want 0.07 divided by 4.6. And I get that, but that doesn't quite look right. Do I have 0.07 divided by 4.6? Yep, that's what I'm getting. Oh, is it a multi? I'm doing the wrong problem. I'm sorry. Let me go back to see what problem we're on. Oh, we're still multiplying. That's my problem. Sorry about that. Thought we were on division. So I'm still going to go back over here. I'm going back and forth and I can't see my problem on my screen. So I got 0.07 times 4.6. Now I got the answer, 0.322. A lot of times in algebra we'll start rounding our answers as we get bigger decimals, but right now let's just keep it. As always, in 7th and 8th grade earlier, if we have 0 wholes, you need to put a 0 in the front of your decimal, and I think we got 322 if I remember right on my calculator. Yep. So it's kind of a little petty thing, but you need to tell the reader we don't even have one whole. Our number's smaller than a whole. Okay? So over here we got negative times a negative, so I know my answer is going to be positive. Now, you can go over to your calculator and you can put in that negative 5.2. Doesn't take that much time, and I want to times, I'm trying to remember, we're multiplying, negative 5, and I get a 26. Okay, so it's all about kind of getting your work done, but doing it accurately. I don't care if you take some of the shortcuts and then just leave your negative signs out when you do your calculator, but kind of in your head, you're saying a negative times a negative is going to be a positive. Okay, all right, here's my division. Dividing with decimals, this is when I really appreciate my calculator, because I see I have a positive divided by a negative, so I know this answer is going to be a negative. But if I go over to my calculator real quick, I can do that problem and let the calculator do all the work. 5.49 divided by, and I'm going to use the negative sign, 0.003, I think it was. And I get 1,830. Once again, like I mentioned yesterday, make sure you put a comma. Any number that's bigger than the hundreds or in the thousands and that, use your comma. Okay. All right. Negative times a negative is a positive. I'll use my calculator. I'm sure you've already got it done. And Fisher, this is taking too long. I want to get my work done. Divided by 0.5. I'm not even going to put the 0 in because I know 0.5 is the same as 0.5. So again, I'm going to try to save my button pushing. I get a 9.7. Hopefully you did too. And it's a positive 9.7. All right, let's go on down to our favorite fractions. Now, if you remember the rule with fractions, we always need a numerator and a denominator. That's the only way we can multiply fractions. If we had a mixed number like 2 1/3, we would need to make that into an improper fraction by taking 3 times 2 plus 1, 6, 7. So that's the same as 7/3. My light just went off because I'm not moving around the room, so bear with me for a minute. I got to run over and turn my light off. After we have 7/3, we can start multiplication. Both of these fractions in our example are already fractions with just a numerator and denominator. Same rule applies. A negative times a negative is a positive, so I know my answer is going to be a positive. And the nice thing about fractions is we just take numerator times numerator, denominator times denominator. 3 times 1 is 3. 5 times 4 is 20. It's a positive answer, and you should always simplify. I can't think of a number that will go into 3 and 20, so I think we are done with that one. Okay, let's go over to this one though. I got 5/12 times negative 12/5. That's an improper fraction, so it probably was a mixed number called 2 2/5. And they already made it improper for us. I have a positive times a negative, so I know my answer is going to be a negative. Now, rather than taking 5 times 12 and 12 times 5, sometimes we can do some cross canceling. Remember this? And it only works on multiplication. So I have 12 times 12 will go into both of those one time. And I can cross cancel this way as well. 5 goes into both of these. 5 goes into 5 one time. 5 goes into 5 one time. Now when I go across, I just multiply. 1 times 1 is 1. 1 times 1 is 1. And 1 over 1 is 1. So my final answer here is -1. All right. Dividing fractions. Here we go. We got one of those mixed numbers. And we have an extra rule. I don't know if you remember or not, but way back in fractions and dividing here, if this was our math problem, 1/7 divided by 4/5, the rule says we always take the reciprocal. That means flip the second number. It's always got to be the second number. Sometimes it works to flip the first one, but you'll find yourself getting into trouble. It doesn't always work. So we always flip the second fraction and change the sign to multiplication. So here's where they did it. They kept the 1/7 the same. They took 4/5 and they flipped it to make it 5/4. Look for cross canceling. 1 and 4, I don't see any cross canceling there. 7 and 5, no cross canceling there. So they just went across multiplying. 1 times 5 is 5. 4 times 7 is 28. There's our final answer. Okay. So here we have to make this improper. So again, the way I taught it in 7th grade is 3 times 5, we put a times sign here and a plus sign up here. 3 times 5 is 15 plus 1 is 16. So we have 16/3. Now, we're going to change the sign to times, but how do I take a reciprocal of -7? There's no denominator. Well, to make your life really easy, to make this equivalent to the same amount, we just put a 1 under that. Because -7 over 1 is the same as -7. Now I have a numerator and a denominator. So I'm going to put the 1 on the top and the 7 on the bottom, because I changed my sign here of multiplication from division to multiplication. I took the reciprocal of the second sign. Make sure you bring the sign down. Now again, I'm going to look for cross canceling. 3 and 1, nothing. 16 and 7, nothing. So we just go straight across. 16 times 1 is 16. 3 times 7 is 21. Positive times a negative is a negative. So -16 21st. And again, I'm thinking, can I reduce anything? I don't think so. 2/9 already a fraction, so I want to bring it down. Change the sign to times, and I want to take the reciprocal of this. 12 needs to go on the top, 7 on the bottom. Okay, let's go. I can see I can cross cancel right here because I know 3 will go into 9 and 12. 3 goes into 9 3 times, so I'll cross that off and make it a 3. I'm reducing it already by 3. 3 goes into 12 4 times. Nothing goes into 2 and 7, so I'm kind of done there. And now we got -2 times 4, which is -8. 7 times 3 is 21. Once again, I want to pause and think about reducing. I don't see anything. Now, sometimes kids will make these fractions into decimals. Let's see if we can do that on our calculator to make our life a little bit easier. So, 2 divided by 9, see, that gives us a big number like this. If you're going to change 2/9 into a decimal, we get a repeating decimal, so we won't get an exact answer. We'll get an approximate answer. So that's why we have to know how to do fractions without a calculator as well as with a calculator to see what 7/12 would end up being. I'm just kind of curious. 7 divided by 12. Yeah, another repeating decimal. So it kind of gets a little bit ugly. All right. So, gotta know how to do fractions without a calculator. Alrighty, and now here's the one that I really meant to put on the other page. This is our 0 divided by -3. What was our answer on this one? Can you remember? I meant to put this on the other page whenever we divide by 0. If you can't remember, just go over your calculator and check it out. Sometimes I can't remember the rule. So 0 divided by -3, and I get 0 again. So anytime we have 0 divided by anything, it's going to be a 0. Okay. If we had it the other way around, we'd have it undivided. That would be a number divided by 0. So that would be like negative 3 divided by 0. We'd get an error over there, 0 error. I want to try getting you to start thinking about the way people, I'm not sure what keeps coming up. Some people's thinking here. And sometimes when they ask you to explain some things, you can kind of explain by showing your math. Is 3/4 divided by a negative 5/2 equivalent to this guy that's outside of the parentheses, 3/4 divided by 5/2? Explain why or why not. Let's do this problem here and see what we get. I have 3/4. I want to change my sign to times. It's a negative and I want to take the reciprocal, 2/5. Look for my cross canceling. And you know what? Instead of the time sign, I'm going to start using the dot because the time's going to start looking like x's. So, don't see no cross canceling. So I get a negative 6. 5 times 4 is, I could have cross canceled. I just see that because that fraction can be reduced. I could have left it, but I see I can cross cancel here, so I'm just going to go back and do that. 3 times a negative 1 is a negative 3, and 2 times 5 is 10. So I get a negative 3/10. Now let's go over to this one. This guy right here is outside the parentheses, so PEMDAS says we have to do the work inside the parentheses first, and then we'll do what's outside. So let's do the 3/4, and then we want to change this sign to times. I said I wasn't going to use the x anymore. And we take the reciprocal of the 2/5. So the 2 goes on the top, 5 on the bottom. Now I still have this negative sign, so I'm going to bring him straight down. Cross cancel still, so that's 2, and that becomes 1. Now I got 3 times 1 is 3, 5 times 2 is 10. Now I still have this negative sign, so I'm going to move this guy down underneath, so I'm working my way down the paper. And I'm going to bring this guy straight down. Now, whenever I have a negative sign in front of a parentheses, we just get lazy in math. Really, there's a negative 1. There's a 1 in front of that, because 1 times anything is still that number. But now I have a negative 1 times 3/10, so I have a negative 3/10. So sometimes in your explaining here, you can do this math to help you now explain it. It says explain why or why not. First of all, we need to say, is it equivalent? Is the first question. Yes, they are equivalent. I don't know, it's going off the page here, so I don't know if you can still see that on your video. And then I want to say, we have to explain. Now this is part of my explanation over here, all my work. And I would say in this one, the first problem, is a positive times a negative. And that equals a negative. The second problem you need to do the parentheses first, which was positive, but then we multiply by negative 1. Make a negative maybe even better. Now that's a lot of writing. I agree. But we're going to do a whole lot of writing, explaining our thinking Now, your wording might not always be the same, so this is what makes me a little bit nervous about Google Forms. How are you going to write all of this into as an answer? So we'll kind of see how that comes up. Right now, your Google Forms is really pretty much just one answer is all you're submitting, and there's really not any other way to put the answer. -4 is just a -4. I guess you could write it out, -4, and it would still kind of wrong if you spelled it out. So all we did is apply the properties of multiplication of integers, that a positive times a positive, or if like signs are the same, it's a positive. The signs are different, it's a negative. Now, you need to complete lesson 2. Now, there's no fractions on today's because I'm still borrowing somebody else's Google Forms. It's an Algebra 1, but it's just really basic 25 little problems of basic multiplication. Just mainly goal is making sure your calculator is giving you the right answer and practicing put it into Google Forms. So once again, when you're all done, you're going to come back to your Google Classroom now, and you're going to click on this guy, Friday's Lessons, submit your work. And here is your Google form that you'll be using to turn your work in. Now, hopefully, you won't have to turn this in. It won't ask you, to turn this in because I just posted it. It shows up as posted. And now, hopefully, I'll just get 30 notifications of saying, in this class particularly, that you got your assignment turned in. Alrighty, you've made it through the first week. Wednesdays are the day that if you have some questions after school, usually about 3:10, 3:15, I'll log on to a Google Meet. And if you have some questions or concerns or things aren't quite working out for you, we'll see if we can do a Google Meet during that time. The other thing that's really kind of being a challenge is some of you are saying in some emails to me or classroom comments, which come across as an email to me, you say, how does it work? And you're not being real specific, or where do I put my answers, or do I make a copy? And you don't tell me what, are you trying to make a copy of? Are you trying to make a copy? Oh, I know what it was. It says, I can't make a copy. And it's like, well, are you trying to make a copy of the PDFs? Are you trying to make a copy of the homework, guided lesson? So if you're going to email me with some of your challenges, make sure you kind of try to tell me what assignment you're working on, what period you're in would really help too, and maybe we can problem solve. I've been trying to keep up with all my emails, but again, since late last night, I got 73 more emails of some kind here today to kind of try to deal with this morning. So it'll get better, I'm confident. And hopefully my videos will start working, that I can start recording them during class time rather than early morning like this. Alright, well, have a good weekend. Turn that paper in so it's not hanging over your head over the weekend. And we will see you on Monday.